I am Raghavan, chemistry faculty from All Force College. So I welcomes you all for the All Force chemistry learning classes, session 17. Okay, in this session today we are going to discuss about the numerical concepts of Bohr's atomic model. In the previous sessions we have done the numericals based on radius of the Bohr's orbit and one electron containing species, and we also done the numericals on energy of the orbit, that is energy of the electron in nth orbit of hydrogen and energy of the electron in nth orbit of species like hydrogen we have done. Okay, that means energy concepts now we are connected, that means we are solving now. Now when electron is revolving in the circular orbit according to Bohr, okay, the potential energy of the electron is given by the potential energy of the electron. Potential energy of electron is given by, that is equals to minus Ze square by, that is potential energy of the electron is given by minus Ze square by R. That is potential energy of the electron is given by minus Ze square by R, and kinetic energy of the electron is given by, kinetic energy of the electron is equals to, kinetic energy of the electron is equals to, that is Ze square by 2R. Ze square by 2R. Okay, that can be represented like this. Then the total energy of the electron in the circular orbit, that is equals to sum of the kinetic energy and potential energy. Okay, that is equals to Ze square by 2R minus Ze square by R, that is equals to minus Ze square by 2R minus Ze square by 2R. That is the total energy of the electron in circular orbit can be represented like this. Okay, and these formulas are very important for us. Definitely we can expect a numerical, that is like what is the ratio of potential energy to kinetic energy. The ratio of potential energy to kinetic energy of an electron revolving in the circular orbit. Okay, like that questions we can expect. Potential energy can be represented like this, and kinetic energy can also be represented like this, and total energy is equals to sum of the kinetic energy and potential energy, that is Ze square by 2R minus Ze square by R, that gives, that represent as minus Ze square by 2R. That is the energy of the electron in the orbit. Okay, done. Okay, this is one part, and next one is potential energy of an electron. Potential energy of an electron is equals to 2 into kinetic energy. 2 into kinetic energy, that is the relation between potential energy and kinetic energy. Then kinetic energy is equals to, potential energy by 2. We know that, yes, from the relation, that is kinetic energy is equals to potential energy by 2. Then total energy is equals to half into potential energy. Okay, this relation is also important for us. Okay, all of you please see in the notebook, you have to keep a separate formula window. In that formula window, from the beginning of atomic structure, you can add all the formulas related to the different concepts. Okay, so that gives your formula window. So based on the formula window, that means when you are thorough with all the concepts, so the formula window you can remember it. Okay, right. So this is about energy concepts. Okay, that is energy concepts we have completed. Okay, that is we can expect the calculate the ratio of potential energy to kinetic energy. So for the ratio purpose we can expect these are the formulas which are helpful for us for all the competitive examinations. Okay, the like EAMCET examination, mains examination, JEE mains examination, advanced examination, and BITS Pilani. Okay, that is BITSAT examination. Okay, very important useful formulas of all this. Okay, direct formulas. Right, now coming to the next concept, that is velocity of the electron. Okay, velocity of electron the derivation of velocity of the electron we already completed. In the previous session, derivation of velocity of the electron in any orbit we completed. Okay, now the same concept again we are taking as a revision part of that. Okay, and we are experiencing some one numerical based on that. Okay, right. So now this is energy concept is completed. Okay, so till last session we completed the radius and energy numericals complete. Then energy numericals, some more extra relations I have taken from potential energy of the electron in the orbit and kinetic energy of the electron in the orbit, and total energy is equals to sum of these two. Okay, that can be represented like this. Okay, you can also calculate. See, for example, based on this we can construct a numerical like this. The energy of an electron is, for example, say it is 1.76 into 10 to the, or wait, let us see like this. Energy of an electron is minus 2.177 into 10 to the power minus 11 ergs. Okay, that is energy of the electron. Energy of the electron is this much in an orbit. So in an orbit of radius, how much? 0.529 angstroms. 0.529 angstroms. Calculate charge on the electron. That is E. Calculate charge on the electron. That he is asking. Okay, what is the question we can make on this formula? The energy of an electron is given like this. That is minus 2.177 into 10 to the power minus 11 ergs. Okay, that is energy of the electron in the orbit. And in the orbit of radius, that means from what distance from the nucleus? It is from 0.529 angstroms is telling us. Then what would be the charge on that electron? Okay, that is the question. Okay, charge on that electron, this you have to calculate. Okay, Z is nothing but hydrogen atom is one only. Okay, doesn't make much difference. So now you have to calculate. That is, energy is equals to, this is minus 2.177 into 10 to the power minus 11. That is equals to E square minus E square by R, 2 into 0.529 angstroms into, see, this is given in ergs. So therefore, radius must be in centimeters. So 10 to the power minus 8 centimeters. This is the data we have to consider. Now we have to calculate E square, and from that E. Okay, the E can be calculated as, that is equals to, that is 4.8 into 10 to the power minus 10 ESU, electrostatic units. So E can be calculated like this. So for this purpose we can expect to calculate kinetic energy, potential energy and total energy of the electron like this. Okay, so for the different concepts we have to make the different formulas. Okay, but the basic fundamental concepts we should be clear in that. Okay, now let us go into the velocity of the electron. Right now, velocity of the electron in any orbit is given by the formula. What is that formula? Velocity of electron in any orbit. Velocity of electron in any orbit. Now, the concept is velocity of electron. Velocity of electron in any orbit, that is equals to velocity of the electron in any orbit, that is velocity of the electron in nth orbit, we can say it is nth orbit. It is equals to 2 pi ZE square by NH. 2 pi ZE square by NH. That is velocity of the electron in the nth orbit can be given by this expression. Okay, this is a basic fundamental formula to represent velocity of the electron in the nth orbit of species containing one electron. That is a common, because Bohr's theory is strictly applicable to the species which contain one electron. Now let us see. Pi is equals to value 3.14. Next, Z is equals to, for hydrogen atom, it is 1, atomic number is equals to 1, and charge of the electron, that is equals to 4.8 into 10 to the power minus 10 ESU, and N is equals to, that is first orbit of hydrogen atom, and H is equals to Planck's constant value 6.625 into 10 to the power minus 27 erg seconds. That is Planck's constant value. Okay. So substituting all the values in this, velocity of the electron in first orbit of hydrogen, you supposed to understand what V1H, velocity of the electron in first orbit of hydrogen atom, that is equals to, substitute all the values, that is 2 into 3.14 into 1 into charge of the electron, that is 4.8 into 10 to the power minus 10 ESU by N, first orbit, into Planck's constant 6.625 into 10 to the power minus 27. Okay, so now velocity of the electron in the first orbit of hydrogen atom, that is equals to, so the velocity of the electron in the first orbit of hydrogen atom, that is equals to, how much it is? That is 2.188 into 10 to the power 8 centimeters per second. This is velocity of the electron in the first orbit of hydrogen atom. Okay, first orbit of hydrogen atom is this much. Then, sir, I want to calculate velocity of the electron in the second orbit of hydrogen atom. For second orbit of hydrogen atom, that means nth orbit of hydrogen atom, velocity of the electron in nth orbit of hydrogen, that is equals to velocity of the electron in the first orbit, that is 2.188 into 10 to the power 8 centimeters per second by N. That is velocity of the electron in the nth orbit of hydrogen atom only. Now let us take up velocity of the electron in the nth orbit of species like hydrogen. Velocity of the electron in nth orbit of species like hydrogen means helium plus, lithium 2 plus, beryllium 3 plus. That is equals to velocity of the electron in the first orbit 2.188 into 10 to the power 8 centimeters per second by N into Z. That is the velocity of the electron in nth orbit of species like hydrogen, means which contain one electron. Okay, so this is the important relations to calculate velocity of the electron. Okay, the basic fundamental, the velocity of the electron in the nth orbit can be represented by this equation. So where we have, so n is equals to nth orbit and z is equals to atomic number of that species. Okay, then so the energy, that is velocity relations given like this. Then it is velocity of the electron in the nth orbit of species like hydrogen, like this. So then velocity of the electron in the nth orbit of hydrogen atom only, nth orbit of hydrogen atom, that can be drawn like this. Okay, so these are the formulas, all the formulas you can keep it in, that is formula window. So you have to basic fundamentally you should remember all the concepts. Okay, that is very, very important. Okay, so this is velocity concept. Now let us work out one numerical based on this velocity. Okay, based on the velocity and number of revolutions also simultaneously we can work out. Okay, the question is like this: calculate the velocity of the electron. Calculate the velocity of the electron in the third orbit of hydrogen atom. In the third orbit of hydrogen atom. Okay. Calculate velocity of the electron in the third orbit of hydrogen atom, and also calculate number of revolutions made by the electron in that orbit per second. Calculate number of revolutions made by the electron in the same orbit, that is n is equals to 3, third orbit only, per second. Okay, that is the question for us now. Okay, it's the velocity nth orbit is done, velocity in nth orbit of hydrogen atom is done. Okay, this is velocity of the electron in the first orbit of hydrogen atom. Okay, done completely, velocity completed. Okay, now we are going to discuss about the numerical. Okay, numerical based on this. See, let us see here only. Yeah. So, what is the question I ask now? Calculate the velocity of the electron in the third orbit of hydrogen atom. So, therefore, third orbit means, let us change. This is third orbit, 3H. So, this is 2 pi z, hydrogen only, atomic number 1, E square, yes, done, E square, sorry, it is E square means 4.8 into 10 to the power minus 10 whole square, it should be whole square. Okay, E square by N 3 and H is equals to Planck's constant. Okay, so now, so based on this, velocity of the electron in the third orbit, this is third orbit, yes, now this is the solution for third orbit. What is the velocity of the electron in the third orbit of hydrogen? Velocity of the electron in the third orbit of hydrogen, that is equals to, okay, velocity of the electron in the third orbit of hydrogen atom, that is equals to, how much we can calculate? That is equals to 2.77, sorry, that is 7.277 into 10 to the power 7 centimeters per second. Velocity of the electron in the third orbit of hydrogen atom, we can calculate it as 7.27 into 10 to the power minus 7. That is centimeters per second. Okay. Now, so what is the continuation of this? Calculate and also calculate number of revolutions. And also calculate number of revolutions made by the electron per second around the nucleus. So, number of revolutions is equals to number of revolutions per second, that is equals to, that is 4 pi square m z square e to the power 4 by n cube and h cube. That is a formula to calculate number of revolutions made by the electron per second. Okay, the derivation of this formula, that is already done in the previous session only. Okay, now I am taking the numerical part of this, right? So in third orbit only you are calculating number of revolutions. Okay, fine. So the number of revolutions is taken like this, and now let us substitute the data. Number of revolutions. Yes, number of revolutions in third orbit. Number of revolutions in third orbit. Per second. That is equals to, okay, now let us see the data, should be very careful. 4 into pi square, that is 3.14 square, M, mass of the electron, 9.1 into 10 to the power minus 28 grams. Atomic number of hydrogen atom is 1 into charge on the electron. Okay, charge on the electron is 4.8 into 10 to the power 4.8 into 10 to the power minus 10 power 4. Okay, e to the power 4 by n cube and h cube. We are calculating number of revolutions made by the electron in third orbit. So that is 3 cube, that is 9 into h cube. H is the Planck's constant value, that is 6.625 into 10 to the power minus 27 erg seconds whole cube. So calculating that is on solving this, so we can calculate the number of revolutions made by the electron is equals to 2.42 into 10 to the power 14. Number of revolutions, finally we can calculate it as 2.42 into 10 to the power 14 revolutions per second. Okay, revolutions per second. So that is the number of revolutions per second made by the electron in nth orbit. That means here it is third orbit. Number of revolutions, how many? Number of revolutions in third orbit per second made by the electron, that is equals to 2.42 into 10 to the power 14. Okay, like that we can calculate number of revolutions per second around the nucleus. Okay, in nth orbit. So now in this session we are doing, we completed some part of the energy, that is the representation of potential energy of the electron in the orbit, the representation of kinetic energy of the electron in the orbit, and what is the total energy of the electron revolving around the nucleus in the orbit. Okay, that we have done. Then next, potential energy, kinetic energy and total energy relations between them. That means these concepts are very useful for our ratio calculations. Okay, for that purpose we understood. And one more point I wanted to mention in the energy only. What is the relation between energy of the electron in the orbit and orbit? That is, say for example, E1 by E2, that is energy of the two orbits and their orbits, that is N2 square by N1 square. So sometimes, very rare cases, this formula is also important for, because energy is inversely proportional to orbit. Okay, right. So we completed energy and we completed velocity, and we also completed the number of revolutions per second. Okay, this is a basic fundamental formula. Based on this formula we can work out on this. Suppose if it is nth orbit, like for example, that is one electron containing species. So Z, we should be very careful, and N orbit. So based on that context, that means suppose I want to calculate the number of revolutions made by the electron in fifth orbit of hydrogen atom. So N is equals to 5. Everything is common. Okay, so that is fifth orbit of hydrogen atom. Say second orbit of hydrogen, N is equals to 2. Everything is common. Okay, now suppose I want to calculate the number of revolutions made by the electron in second orbit of lithium 2 plus. Second orbit means 2, N is equals to 2. Lithium 2 plus atomic number, lithium atomic number 3. Okay, so like that substitution and careful calculations give the correct result. Okay, so that is the brief description about velocity of the electron is done, and number of revolutions made by the electron around the nucleus per second is also completed. Okay, now coming to the next concept, that is number of waves. Next concept. Okay, the next concept is number of waves made by the electron per second. Okay, number of waves made by the electron, number of waves made by the electron around the nucleus. Okay, number of waves very important point. You can also find this type of question in the integer type of numericals. Okay, now coming to the number of waves. Number of waves. Number of waves made by the electron. Okay, right. See, the number of waves made by the electron, that already we have done that. Okay, that means number of waves in any orbit, number of waves in any orbit, that is equals to n. Already we already completed the derivation part. Okay, now just I am taking the revision part of that. So number of waves in any orbit, that is equal to n value. Simple. That is equal to n value. For now, example 1. How many waves made by the electron in the second orbit? Okay, how many waves, that is number of waves made by the electron in second orbit. Number of waves made by the electron, number of waves made by the electron in second orbit, is equal to 2, because n is equals to 2. So that is why 2 waves are made. Number of waves 2. Next, let us take one more example. Second example, number of waves made by the electron in fourth orbit. Orbit number is given 4. Therefore, number of waves are how many? 4. One more example let us take. Third example, number of waves made by the electron in sixth orbit, that is equals to orbit number is 6. That is why number of waves are also 6. Like that, very simple. Okay, so it is simple and very interesting and very, very important concept. The number of waves made by the electron in nth orbit, that is equal to orbit number or energy level. Okay, in sixth orbit, how many waves made by the electron? It is 6. In second orbit, that is in second orbit, how many waves made by the electron? It is 2. So in fourth orbit, how many waves made by the electron? It is 4. So right, so we have completed up to this. So after this concept, okay, so shall we go into the next concept? That is, see, with this we completed the Bohr's theory is completed. Totally it is completed, because in Bohr's theory, what are the concepts we completed? First we observed that what are the important postulates of Bohr's atomic model, and from that we learned that Bohr's equation to calculate radius of nth orbit of any species which contain one electron. That means derive an equation to calculate radius of nth orbit. Done. It is completed. Next, derivation of equation for energy of the electron in the nth orbit of species containing one electron. That also completed. Next, calculate, that is, or derive the equation to calculate velocity of the electron in nth orbit of species containing one electron. That also completed. Radius completed, energy completed, velocity completed. Next, calculate number of revolutions made by the electron around the nucleus per second, the species which contain one electron. Yes, that also completed. Now, with this, the number of waves made by the electron around the nucleus, that also completed. That means Bohr's atomic model successfully explains the spectrum of one electron containing species like hydrogen atom or helium ion, He plus ion, or lithium 2 plus or beryllium 3 plus ions. We completed all this. Okay, now coming to the, okay, so these are the some important interesting features of Bohr's atomic model. Yes, we have done, completed. Next, what are the drawbacks of Bohr's atomic model? So drawbacks of Bohr's atomic model, we learned that yes, Bohr's theory is applicable to only one electron containing species. Bohr's theory failed to explain the spectrum of multi-electron species. Okay. It failed to explain the spectrum of multi-electron species. Very good. That is first drawback or limitation. Second, we can say in Bohr's theory we know that electron is revolving around the nucleus and the angular momentum of the electron is quantized around the nucleus. But in circular orbit, Bohr's theory failed to explain the reason for the quantization of angular momentum in circular orbit. Okay, so that is one. Next, Bohr's theory failed to explain the fine spectrum of hydrogen. Bohr's theory failed to explain splitting of spectral lines under the influence of magnetic field, that is Zeeman effect, and splitting of spectral lines under the influence of electric field, that is Stark effect. That means Bohr's theory failed to explain Zeeman effect and Stark effects. That means splitting of the fine spectral lines under the influence of magnetic field as well as in electric field. Bohr's theory failed to explain electronic arrangement naturally. Does not explain electronic arrangements. Does not explain formation of chemical bonding. Okay. So these are the some important drawbacks of Bohr's atomic model. Okay. So right.